Hello everyone, welcome to the Construction Technology course. Today, our main topic is methods of construction dewatering and groundwater lowering. Through this lesson, we aim to cultivate your engineering thinking and innovative awareness, develop your ability to analyze and solve practical engineering problems, equip you with professional skills, and guide you to embark on a path of career success and national service through technical excellence. First, let's discuss construction dewatering. During foundation pit excavation, if the groundwater and surface water flowing into the pit are not promptly drained, it will worsen construction conditions, potentially causing soil wall collapses and reducing the bearing capacity of the foundation. Therefore, construction dewatering can be divided into two methods: open drainage and artificial groundwater lowering. First, let's look at the open drainage method, which generally involves three approaches: interception, diversion, and pumping. Interception requires installing temporary or permanent drainage ditches, flood channels, or retaining embankments around the site to block rainwater and shallow groundwater from flowing into the work zone. Drainage refers to setting up a grid of drainage channels to channel and remove surface water from the site. Pumping involves installing sump pits and drainage facilities in low-lying areas, and then discharging the water using pumps. Specifically, one common approach is the open ditch and sump drainage method. This method involves excavating open drainage ditches along one side or around the foundation pit, with sumps placed at each corner or every 20 to 30 meters. The drainage ditches are kept about 0.4 to 0.5 meters below pit bottom, while the sumps are 0.5 to 1 meters deeper than the drainage ditches. Water pumps are installed in the sumps to pump the water out of the foundation pit. This method is suitable for foundation pit with relatively good soil conditions and limited groundwater. Another method is layered open ditch drainage, when the foundation pit consists of multiple soil layers with highly permeable sandy soils. To prevent upper groundwater from scouring the lower slopes of the foundation pit, it is necessary to construct open ditches and corresponding sumps in layers along the pit slopes. This method is suitable for deep foundation pits with a high groundwater table and permeable upper soil layers. Now, let's learn construction dewatering. When excavating large foundation pits in water-bearing soil layers below the groundwater table, the open ditch drainage method often fails to effectively remove large volumes of groundwater inflow. When silty fine sand layers are present, serious problems such as soil heave, mud boiling, and sand boils can occur. These issues not only make it impossible to excavate the foundation pit to the required depth, but may also lead to severe soil and water loss, slope failures, and ground subsidence in surrounding areas. In extreme cases, they can even endanger nearby buildings. In such situations, artificial dewatering methods, such as well point dewatering, are used for construction. Now, let's explore the functions of well point dewatering. Firstly, it prevents groundwater from entering the foundation pit. Secondly, it prevents slope collapse caused by groundwater seepage. Thirdly, it relieves the pressure caused by the groundwater level difference in the soil layers of the foundation pit. It can prevent piping at the pit bottom. Fourthly, after dewatering, it reduces the lateral loads on sheet piles. Fifthly, lowering the groundwater level also promotes soil consolidation, which increases the bearing capacity of the foundation soil. Moreover, by eliminating groundwater seepage, it prevents quicksand conditions. Next, let's take a look at the main types of well point dewatering. The first type is light well point dewatering. The second is ejector well point dewatering. The third is electro-osmotic well point dewatering. And the fourth is deep well dewatering. Let's focus on the first type, light well point dewatering. Light well point dewatering involves installing well point pipes around the perimeter of the foundation pit and embedding them into the aquifer. Using pumping equipment, groundwater is continuously extracted from the well point pipes, lowering the groundwater table to below the pit bottom. This method is suitable for soil layers with a permeability coefficient of 0.1 to 50 meters/d. The achievable dewatering depth is 3 to 6 meters for single-stage well points and 6 to 12 meters for multi-stage well points. Next, let's examine the equipment for light well point dewatering. It consists of a piping system, including filter pipes, well point pipes, swing joints, and header pipes, and pumping equipment, including vacuum pumps, centrifugal pumps, and air water separators. The working principle of light well point dewatering and the structure of the filter pipes are illustrated in the following diagram. Now, let's move on to the plan layout methods for light well point systems. The first is the single row layout, when the width of the foundation pit or trench is less than 6 meters, and the dewatering depth does not exceed 5 meters. A single row layout can be used. The well point pipes should be installed on the upstream side of the groundwater flow, with extensions at both ends, preferably not less than the width b of the pit or trench. The second is double row layout. When the width of the foundation pit or trench exceeds 6 meters, a double row layout can be adopted. The third is circular or U-shaped layout. For large area foundation pit, a circular layout should be used. If construction machinery needs access, a U-shaped layout is preferable. It should be emphasized that when adopting double row, circular, or U-shaped layouts, the spacing between well point in the upstream row relative to the groundwater flow should be smaller, while the spacing in the downstream row can be larger. If a U-shaped layout is used, the open end of the well point array shall be oriented downstream of groundwater flow. Next, let's take a look at the design and calculation of light well point dewatering systems. The design of the well point system should be based on materials such as the site topographic maps, hydrogeological investigation data, and the construction drawings of the foundation pit. In addition to the plan and elevation layout of the well point system, the design should also involve calculations of water inflow, determination of the number of well point pipes and their spacing, and selection of pumping equipment. Next, let's examine the installation procedure for light well points. The first step is to lay out the header pipe. The second step is to install the well point pipes. The third step is to connect the well points to the header pipe using swing joints. The fourth step is to install the pumping equipment. Alright, class, today we have mainly learned about construction drainage methods and groundwater lowering. Has everyone got it? Please make sure to reinforce your understanding through construction simulation software training after class.